All right, students, welcome to the next lesson for our linear unit. In this lesson, we're looking at linear inequalities. So chapter 1E on linear inequalities. So our intention for today is to be able to represent what an inequality is on a number line. All right, so that's the sort of the main gist of today. Representing an inequality from a number line on a number line. And obviously you've learned how to solve linear inequalities, equations, which are basically the same as solving linear inequalities. So today, as a success criteria, you can interpret what's an inequality statement. Also represent inequalities on the number line. So remember, a number line is basically just a line with a bunch of numbers in it. That's a number line. Okay, I forgot one. We can write an inequality for a number line. So see an inequality here and then write it, and then solve an inequality statement and represent it on a number line. So basically everything revolving around inequalities and number lines is what you're focusing on for this lesson. All right, so let's get into this starter activity. If x is 0, does this following statement make sense? Okay, so if x equals 0, does this statement make sense? So there are a couple of things we need to look at this, okay? You've got these little symbols here. These are your inequality symbols. This, okay, or these symbols, sorry, I should mention, we always read from left to right. So you're reading them that way. So if you're looking at this symbol, okay, that is what you'd call a less than. So this is a less than symbol. Oh, not 10, less than. And this symbol here is greater than. Okay, because reading it from left to right. Less than, greater than. Okay, that's what these symbols mean. You've also got this symbol. Okay, it's the same thing, but with a line underneath. So this is saying less than, less than or equal to. Okay, that's what that symbol means now because of that line underneath. So this will be greater than or equal to. So that's just a bit of a recap of what those inequalities mean. Okay, so that's what that means. So let's solve this. What can we do, okay, to figure out what these values are? If x equals 0, will these make sense? So all you got to do is change x to 0 in all of these and then solve it. So that's going to be 5 times 0. Actually, let's put it over here. We'll use another color as well, so it doesn't get too confusing. So let's put zeros for all of these. Okay, so it's going to be 5 times 0 plus 6. That's one of them. Is less than 6 times 0 plus 4, which is less than 5x plus 5 times 0, sorry, plus 9. So if we try and solve this, this basically gets rid of all of those terms with the x's. So 5 times 0 is 0, so you're left with 6, is less than 6 times 0 is 0, so you're left with 4, which is less than 5 times 0 is 0, and you're left with 9. Okay, so if we look at this, does this statement make sense? 6 is less than 4, 4 is less than 9. Okay, well, part of this statement makes sense, where 6 is less than 4, but part of this statement is correct in that 4 is less than 9, not bad. But 6 is less than 4 does not make sense because 6 is greater than 4. Okay, so this statement doesn't actually make sense. Can we think of any values then, apart from 0, to make this statement correct? Okay, well, I'll leave that up to you, but there are different numbers that you can use, okay, instead of using 0 to make this statement make sense, okay? And I'll give you a clue. You might need to use some negative numbers, which we will figure out a little bit later on. So let's get into it. An equation is basically a statement of equality, which means basically an equation just represents a variable and what it equals. Okay, so in this case, x, or the letter x, is the same as or equal to 17. A linear inequality is a statement such as x is greater than or equal to 17, which means that x can be a value or any value greater than or equal to 17. Okay, that's what this is saying. So x can be anything that's greater than or equal to the number 17. Okay. And this also makes sense the other way. So if you went 17 is less than or equal to x, it means the same thing, yeah? X is any number that's greater than 17 or equal to 17. I already went through this. Okay, so just have a read through it if you still don't understand it. But basically, watch those symbols. Okay, this means that x is less than x, x is greater than x, x is less than or equal to x, and this means that x is greater than or equal to whatever the number is. Okay, look at this statement. This is saying x is less than 5. Which means that all of the values of what x can be have to be lower than 5. This means that x is greater than or equal to 7, which means that x can be any number that is 7 or bigger than 7. Okay, so what do you think 2 is less than x means? What could be some of the solutions for x? So have a think. 2 less than x. So what could the numbers be? Well, 2 is less than x, which means that x can be any value that is bigger than 2, because 2 is less than x. Okay, and it doesn't have the equal to sign, so it's any number that's bigger than 2, which means that can be 3, 4, 5, 6, or 7. An easier way to understand this statement is to just put that variable on the left-hand side. So just basically swapping them. But if you are going to swap them, you got to make sure that you are aware that the symbol has to be reversed. Okay, so like for example, 2 is greater than less than x is the same as x is greater than 2. Okay, and therefore it still falls within that solution. So if you're gonna do this technique or this little trick of making it easy to understand, putting x on the left hand side, make sure that that symbol gets swapped. So originally it was this, and now when you put the x on this side, okay, that symbol has to get reversed for it to make sense. Otherwise you're changing it and it wouldn't make sense anymore. So representing inequalities on your number lines. So you're going to use number lines to represent what we call obviously these inequalities. So there's a few different types of inequalities that can be represented. So you've got your standard inequality, where it's literally just your basic x is greater than 4, x is less than 4, x is less than 7, just one sort of statement like this. And this is how we represent it. Okay, and as you can see here, this is saying x is less than 4. So that means I want every number that is less than 4. So you're going to put a circle on top of the 4, and then your arrow going that way. All the numbers less than 4. Notice how as well, the circle is not colored in. It's not filled, because that coincides with this symbol. If, okay, this symbol had a equal to, then this would be colored in, but it's not. Okay, so keep that in mind. You can have combined inequalities where it tells you that x is between two numbers. So in this case, -2 is less than or equal to, so x, is less than or equal to x, and then x is less than or equal to 7. So that means x is somewhere between -2 and 7, and you put that in your number line, like so. Union inequality, that means you can have two different inequalities happening. Okay, so it's basically the same as this, but just two of them on the same number line. All right, again, watch out for the circles and how you draw them. If it's equal to, then you need to color in your circle. If it's just a normal one like this, then leave your circle blank. So let's try some examples. X is less than 5. So on my number line, this is how I normally do them. X is less than 5. Draw your number line. You don't need to draw every single number. I can just say that there's 5 there. This number line represents X, so make sure you label it. And from there, you know that X is less than 5, so you're going to draw a circle on top of 5. And I want all the numbers less than 5, so you're going to point towards any number less than 5. You don't necessarily need to write anything else here, although you'll see in these examples, they've written at least a number on the other side too. So we can put 0 there if you want to. Not necessary though, okay? But let's just do it for this one. Next one, x is greater than or equal to 6. Oops. So in this case, drawing a number line, it's saying that x is greater than 6 or equal to 6. So drawing a number line, I'm going to put 6 here. The reason why I want to put it here, because I'm focusing on all the numbers bigger than 6. Okay, so that means, oh, one thing I've forgotten that you have to include here is the circle must be colored in because it's equal to 6 as well. So you must color in that circle. X is less than negative 2. All right, so if negative 2 is here, I'm focusing on all the numbers less than negative 2. So color, actually don't color that in because it is not equal to. Okay, it's just x is less than negative 2. You don't have to do this either, but I do like to do it just to make it clear. All right, here we've got a range here. Okay, this is saying that x is greater than negative 3, or negative 3 is less than or equal to x, but x is less than 0. So what this is saying is that the value of x has got to be between negative 3, okay, between negative 3 and 0. So let's put our circles there. Okay, put a line through and be mindful of, again, what's equal to. So in this case, it's equal to negative 3. So let's color in that one. We can leave 0 because it's not equal to. Here's another one. X is, so negative 5 is less than x. X is greater than 3. Okay, so on my number line, again, this, oh, by the way, will probably take some knowledge of your negative numbers. Okay, just watch out for understanding how your negative numbers work. So that's between negative 5 and 3. Do your circles, join them. Okay, and then have a look at where it's equal to. There's no equal to sign, so we can leave it as is. Okay, this is saying 4 is less than or equal to x, and x is less than 10. So it's between 4 and 10. 4, 10, do your circles, join them. Okay, and have a look for any equal signs. So I can see that it's equal to 4. So that means x is going to be between 4 or equal to 4 and up to less than 10. All right, now here you've got two inequalities happening. This is saying that x is less than negative 4, or less than or equal to negative 4, or it's also greater than 3. So this one's a bit trickier. Okay, when you've got two inequalities happening at the same time, you got to make sure you draw on the same number line. So this is saying x is less than negative 4. So let's put negative 4 here. So let me put it a bit more here. Negative 4. So this is saying x is less than or equal to negative 4. Make sure you color it in. But also x is greater than 3. So let's say 3 is here. So x is greater, okay, than 3. Okay, that's what that's saying. Now there's no equal to sign, so we can just leave it. Okay, so that's how that inequality will work. Okay, now this one here is a bit trickier as we haven't come across it yet, where you need to solve an inequality. Now we will get to that a bit later, but let me actually show you how to solve this. It's the same principle as if you were solving a normal equation. So make sure the x is isolated. This is a plus 5. Get rid of this. It becomes minus 5. Therefore, x is greater than 10 minus 5 is 5. And then the other one. Okay, this is a x plus 5 is less than or equal to 3. So this is a plus 5 here. When you move it here, it becomes minus 5. So that means x is greater than or equal to 3 minus 5 is negative 2. All right, so drawing that on my number line. I might do that down here. Oops, sorry guys. Trying to make it as straight as I can. All right, let's do this first one. X is greater than 5. So 5 would be somewhere on this side. Okay, it's greater than 5. So x is greater than 5, which is there. Now, there's no equal to sign, so we can just leave it. The other one is x is less than or equal to negative 2. I might just draw this in another color so that you guys won't get confused about it. Okay, so this again I've solved by getting rid of that. Positive 5 becomes negative 5, so x is less than or equal to negative 2. So I'm going to draw that here. Negative 2 would be here. The reason why I do this is I want you to understand the number line. Okay, negative 2 is always going to be less than 5, so it has to be on this side. Okay, less than or equal to negative 2, and make sure you color it in. All right, let's get into some solving so we can understand how this works. Solving inequalities follows the same rule as solving linear equations. The only difference is when you dividing or multiplying by negative, you have to reverse the inequality sign. Okay, so that's just the only caveat that you have to remember when multiplying or dividing by a negative number. Consider 4 is greater than 8, less than 8, which makes sense. Okay, if you multiply both sides by negative 1, what do you think might happen? Okay, well, if we did that, have a think. If you multiply this both by negative, when you get negative 4 is less than negative 8, which doesn't make sense. Okay, because negative 4 on your number line is actually greater than negative 8. If you think about it, let me draw your number line here. Okay, there's negative 4, negative 5, negative 6, negative 7, negative 8. See how negative 4 is high on the line, the negative 8? So this statement does not make sense. Okay, that would not make sense. So what happens, okay, is that when you multiply by a negative, you have to reverse that symbol. So what happens is that negative 4 has to be greater than negative 8 because that symbol gets reversed. Okay, let's see that in principle. So let's solve some of these equations and then put them on a number line. This is a basic one. There's no negatives, which is good. So let's see what we can do. We're not multiplying and dividing by negatives. So here, plus 4, bring it to the other side, becomes minus 4. So you're left with 3x is greater than 13 minus 4 is 9. Okay, what you're left with now is 3x is greater than 9. Isolate the x, get rid of that 3, it becomes divide. So that means x is greater than 3. Now, I haven't divided by a negative number, so that symbol will not get swapped. Draw it on my number line. There's 3. This number line is called x. X is greater than 3. So I want all my numbers that are bigger than 3. Okay, easy. 4 minus x over 3 is less than or equal to 6. So let's do this one. Start off by getting rid of that 4. It's a plus 4, so it becomes minus 4. And you're left with negative x over 3 is less than or equal to 6 minus 4 is 2. Okay, now here we're going to be multiplying, okay, because this is x divided by 3. Let's move that divided by 3. Now, watch out because this is a divided by negative 3. So if I get rid of it and I bring it to the other side, it becomes multiplied by negative 3. Okay, so now this is where that rule from that previous slide comes into play. When you divide or multiply by a negative, you have to reverse that symbol. So that means now x is greater than or equal to, I've reversed that symbol, 2 times negative 3, negative 6. Okay, so put that in my number line. X is greater than negative 6. So if negative 6 is here, x is bigger than that number, and we color it in, okay, because it's equal to. And this is the number line called x. Last one, 3x plus 2 is greater than 6x minus 4. Now you've got inequalities on both sides. Terms on both sides. So we have to put them both on the same side. So that means this is a 6x. It's a plus, so if you bring it here, it becomes minus 6x. And this is a plus 2. So when you bring it here, it becomes minus 2. So let's rewrite this. So you get 3x minus 6x is greater than negative 4 take away 2. Okay, so 3x minus 6x, let's evaluate that. You get negative 3x greater than negative 4 minus 2, or that equals negative 6. Isolate that x. This is a multiplied by negative 3. So if I bring it to the other side, it becomes divided by negative 3. And interestingly, remember, if you've divided or multiplied by a negative, that symbol will get swapped. And negative 6 divided by negative 3 gives you 2. So this is saying x is less than 2. So I put 2 there. X is less than 2. Okay, hope that's made sense. Now I want you guys to try these examples. So you can pause the video and do these questions. Otherwise, I'll do the solutions now. All right, so same principle, yeah? Let's isolate that x. This is a plus 5. Bring it over here. Becomes minus 5. You're left with 2x is greater than 11 minus 5 is 6. Okay, so you've got this 2. Get rid of it. It's a multiply by 2. Here it becomes divided by 2. No negatives involved, so that means that symbol stays the same. 6 divided by 2 is 3. So on my number line, x is greater than 3. Don't need to color it in because it's not equal to. Okay, let's do this one. This is a plus 2 or a positive 2. So if I bring it here, it becomes minus 2. So you've got negative x over 3 is less than or equal to 4 minus 2 is 2. Okay, here you've got a divided by negative 3. So if I bring it to the other side, it becomes multiplied by negative 3. Therefore, you're left with x is less than or equal to, actually, oops, don't forget what happens when you multiply divide by a negative symbol. That symbol will get swapped. The greater than or equal to symbol gets flipped around. So 2 times negative 3 is negative 6. So this is saying x is greater than negative 6, greater than or equal to negative 6. So you've got negative 6 here. X is going to be greater than that. Just notice my horrible arrows. Oh, my arrows are really horrible. So sorry, guys. All right, last one. Okay, inequalities where you've got two variables on both sides. So remember, you want to try and put them together. All right, and I always like to put my x on the left-hand side as it just makes understanding that inequality easier. So for this scenario, you're going to move that 7x, it's a plus 7x to this side. So it becomes minus 7x. This is a plus 1, so here it becomes minus 1. Okay, so you've got 4x minus 7x is greater than negative 2 minus 1. 4x minus 7x is negative 3x. That's greater than negative 2 minus 1 is negative 3. Okay, this is a multiply by negative 3, so if I bring it here, it becomes divide by negative 3. By the way, you don't have to keep doing this if you don't want to. I only do it so that it helps you guys make sense of it. But if it doesn't make sense, maybe let me know and I'll stop doing those arrows. So remember, I've divided here by a negative number, so that symbol must get swapped to this one. Negative 3 divided by negative 3 gives you 1. So x is greater than 1. Okay, and there is my number line inequality for it. All right, so just a quick recap. Linear equalities have multiple or infinite solutions. Okay, like so this is an inequality saying x is less than 1. So this is saying that x can be less than 1. And that means there's multiple infinite solutions. The following symbols help us to identify a solution. So remember what these represent. You can represent an inequality statement on the number line. Okay, like so. So you've got your number line. Don't have to include every numbers, but let's just say that, you know, x is greater than 1. There's your number line. Okay, that's what that corresponds to. You can solve inequalities like solving linear equations. So that's the same principle, yeah? And probably the last thing to remember is every time you multiply or divide by a negative number, you have to reverse that inequality, okay, for it to make sense. Cool. So go off and do exercise 1E at page 30. So do these questions, please. Thank you.